Okay, today we're going to be looking at solving linear equations. Now before we get started, let's look at what those three terms mean. That will give us a better sense of the mathematics. So linear means that the equations we're going to be looking at don't have any powers. There are no powers in linear equations. Equations, well, they have an equal sign. And finally, solving. What does it mean to solve these equations? Well, it means we're going to be finding the value of x. Sometimes it's a different letter, but more often than not, we use x, which is just a historical reason for using x, and no other reason apart from that. So, first example we're going to be looking at 3x plus 5 is equal to 6x minus 7. Okay, and if you are going to be filling out a form later to show that you've watched the video, the country you were looking for was Russia. Next, so 3x plus 5 is equal to 6x minus 7. Okay, so we've got a left-hand side of the equal sign and a right-hand side of the equal sign. Now our goal is to find out the value of x. So we're going to manipulate the equation in order to isolate x and get it x on its own on one side. We can treat the equation like a balance. On the left-hand side and the right-hand side, it could be like a set of scales, and both sides are in balance. So, if we think about the scales then, on the left-hand side we have 3x's and 5, and on the right-hand side we have 6x's and minus 7. Okay, so with a set of scales, each operation we do, each time we manipulate the equation, we must keep these scales in balance. Now the first thing we could do is we could take off 3x's from both sides. That will keep the scales in balance. So we take off 3x from this side and from the other side. If we take off 3x from the left hand side, we have no x's left, we're just left with the 5. If we take off 3x's from the right hand side, 6x take away 3x, that's 3x. And we still have the minus 7. If I go back a step there, if I'm going to get rid of the 3x's on the set of scales, I just rub them out, and I take away 3x's from the right hand side of the set of scales. So you can see how the equation in red is the same as the scales in yellow there. Right, the next thing I can do, well, I want to get x on one side on its own, so I'm going to add 7 to both sides. Okay? When I add 7 to the left hand side, I'm left with 12, and on the right hand side I'm just left with 3x, because minus 7 plus 7 is nothing. On the scales then, I'd be adding 7, which gets rid of that minus 7, and on the left hand side I'd be adding 7 to give me 12. Okay, I'm going to just go back there. Now for the purposes of the next thing, I'm going to rewrite 12 as 12 ones. Okay? I've got 12 there. Okay. Right, so now if we look at the equation, the blue equation, I've got 12 is equal to 3x. I'm going to divide both sides by 3. Because I can do that with a set of scales. I can half both sides, I can quarter both sides, I can divide both sides by 3. If I divide this left-hand side by 3, I'll be left with 12 over 3. And the right-hand side, 3x divided by 3 is just x. Right? 12 divided by 3 is 4, so that means x is 4. You can see what I've done there on the scales as well, as I've split it into 3 sets of 4. So you could see how each x would match up with a set of 4. So each x is equal to 4. Hopefully that makes sense with both representations. Okay, so the value of x is 4. Now, note, it doesn't matter in which order we manipulate the equation. So we can manipulate the equation in any order. I'm going to rewrite the equation, 3x plus 5 equals 6x minus 7, and we're going to manipulate it in a different order, and we will still get the same answer. So, to start with, instead of minusing 3x like I did in the first example, I'm going to take away 5 from both sides. When I take away 5 from the left-hand side, I'm left with 3x, and on the right-hand side, I'll be left with 6x minus 12. Okay, now I want to get x on its own. So I'm going to take away 6x from both sides. When I take away 6x from the left hand side, I'm going to write the equation, we'll deal with that in a second, so I get 3x, take away 6x. When I take away 6x from the right hand side, I've got no x's left, I'm just left with that minus 12. Okay, so 3x take away 6x, what is it? Well, it's just minus 3x, and the right hand side stays the same. So now I want to get x on its own, so I'm going to divide through by minus 3. Okay. When I divide through by minus 3 on the left hand side, I'm left with x on its own, and on the right hand side I could write this as minus 12 divided by minus 3. Now minus 12 divided by minus 3, that's just 4, as it was in the first way we did it. So this makes sense because maths makes sense. If you've got a different answer, it would be wrong. We're going to check this now. So if you're not sure about an answer, you can always check it. What do I mean by checking it? Well, we can, if x is 4, does the equation make sense? So that's what it means by checking. If the x is 4, does the original equation make sense? In other words, is the left-hand side equal to the right-hand side in the original equation? Okay. So I could substitute x for 4 in the first equation. So I'm going to do 3 times 4. 3 times 4. And add 5. That's the left-hand side of the original equation. Now the right-hand side is 6 times 4 minus 7. Okay. Now is the left-hand side equal to the right-hand side? So let's deal with the left-hand side. 3 times 4 is 12, add 5, that's 17. On the right hand side, 6 times 4 is 24, minus 7, that's also 17. So, yes, the left hand side is equal to the right hand side. Okay, and if you're looking for the animal, in the multiple choice quiz to show you've watched the video, the animal is the hedgehog. Okay, so yes, the left hand side is equal to the right hand side. Okay, in the next linear equation, we're going to do a slightly more challenging one and just show how that would work. The previous one, if I go back to the previous page, was a fairly simple one using basic manipulation. The next one's just slightly more complicated. Okay, so 2 times by 3x plus 2, take away 7, is equal to 6 times 5x minus 7. Okay, so the first thing we're going to do is we're going to multiply out both sets of brackets. Okay, we're going to expand both brackets. So on the left hand side, when I expand that bracket, I'm going to get 6x plus 4. Okay, that comes from 2 times 3x, which is 6x, and 2 times 2, which is 4. Okay, then I've still got that minus 7. Now I expand the right hand side, I get 30x from the 6 times 5x, and minus 42 from the 6 times minus 7. Okay, next. I can combine the plus 4 and minus 7. Okay, so I keep the 6x there, and 4 minus 7, that should be minus 3. I'm just going to change that now. Yeah, so 6x minus 3, and the right hand side stays the same, so 30x minus 42. So what I'm going to do now, well, I could take away 6x from both sides, and if I take away 6x from the left hand side, I'm just left with that minus 3. Take away 6x from the right hand side, I get 24x minus 42. I could then add 42 to both sides. Adding 42 to the left hand side gives me 39, and then adding 42 to the right hand side means I get rid of that minus 42, so I'm just left with 24x. Okay, so now I've got 39 is equal to 24x. I can divide both sides by 24. Before we do that, if you're looking for the George, it's George of the Jungle. Okay. So I can divide both sides by 24. I'm going to write these as fractions. 39 over 24 is equal to 24x over 24. Now notice how the 24's cancel, so I'm just left with x. Okay? On the left hand side, there's a common factor of 3 between the numerator and the denominator. So the denominator cancels out to 8 and the numerator to 13. So x is 13 over 8. if you want to write that as a mixed number, that's 1 5/8. Okay, so the key points to remember are: firstly, do the same to both sides. So if you add something to one side, you have to add it to the other. If you divide one side by something, you have to divide the other side by the same thing. Okay, so to solve a linear equation means we find the value of x, or another letter if that's the case, but normally it's x. And finally, check your answer if you're not sure. Okay, check your answer if you're not sure. Okay, thank you for watching.